Okay, let's take a look at the quotient rule. What's a quotient? Well, we've got something divided by something else, right? And so we've got a smaller function than the big capital F of x, and we've got another function which is being divided by the first one. So we've got something that looks like f of x over g of x, where f of x is equal to x squared plus 1, and g of x is equal to x to the power of negative 2 minus 1. And how are we going to figure this one out? Well, we're going to have to use this quotient rule, and it's a little more, there's a couple more steps than the product rule. So we've got a little recipe in English here. The derivative of the quotient, that's the big f prime of x, is the denominator, g of x, times the derivative of the numerator. So that's going to be f prime of x. That whole thing minus the numerator, that's f of x, times the derivative of the denominator, that's g prime of x. And the whole thing is going to be divided by g of x squared. The whole thing squared, the whole function squared. Now we've got an example here. So let's break this example. Let's use this example to find the derivative of big f of x. And the first thing we're going to do is we're going to take the derivative of the numerator. So that's 2x. That's my f prime of x. And I'm going to multiply it by what? I'm going to multiply it by g of x. G of x is x to the power of negative 2 minus 1. The next part of my recipe is minus, so I'm going to subtract the numerator, that's f of x, multiplied by the derivative of the denominator. And so what's the derivative of the denominator? Well, I apply the power rule to the denominator, and I get negative 2x to the power of negative 3. And I guess I don't just want to write f of x there. I actually want to write in what it is in our specific example. And I've got f of x, and then here I've got g prime of x. But I'm not done. I've got one more step, and I want to take the denominator and I want to square it. So I'm going to write x negative 2 minus 1, and I'm going to square the whole thing. And this ugly looking expression is f prime of x. Now I could clean up this expression a little bit and simplify it. Sometimes on tests I will ask you not to simplify because I just want you to show me that you can take the derivative, and once you start simplifying you're more likely to make a mistake. I don't really want you to do that. Here I'll try and clean it up just a little bit. And so we can multiply out these brackets, and I'm going to get 2x to the negative 1 minus 2x. Then I've got a minus sign here, and then I'm going to put a bracket like that because I want to multiply out. Oh no, maybe I don't need to do that. I'll just put a negative sign there, and I'm going to have a plus 2x to the negative 1. And plus 2x to the negative 3. Divide this whole thing. Maybe I'll just leave it, the denominator, the way it is. So I'll just write out the denominator like so. I don't think we're going to be able to do much with that. and I can see that looks like these two are going to cancel each other out, and I'm going to have negative 2x plus 2x negative 3 divided by, well, I'm not going to do that. And so, you know, we could maybe do something, factor something out up in the numerator, but we're not really going to be able to do too much with simplifying this rather ugly expression. Let's formalize the rule. So if we want to find the derivative of big f of x, it's going to be equal to the derivative of the numerator times the function in the denominator minus the function in the numerator multiplied by the derivative of the denominator, and that whole thing is going to be divided by the function in the denominator squared. Let's take a look at this expression here. We've got an economic problem. So we've got a quantity Q and a total cost function C of Q. And we've got this combined function big F of x, which is equal to the total cost divided by units produced. What's that equal to? It's equal to the average cost. And so this f of x is the average cost. We want to find the derivative. So let's use the quotient rule to find the derivative of big F of x. And so it's going to be equal to the derivative of the numerator, right? This is an abstract conceptual question, so we don't actually have numbers to work with. So I'm just going to write C prime of Q, right? That's the derivative, the first derivative of the cost function, multiplied by Q, the denominator, minus the derivative of the denominator multiplied by the numerator, the cost function. And the whole thing is going to be divided by Q squared, because we take the denominator and we square it. Now, rewriting this, we have the change in average cost is equal to here's where we're going to use a little economics with the mathematics that we've derived. So I'm going to do some rearranging here. I'm going to factor out a 1 over Q. And then I'm going to write C prime Q minus CQ over Q. And then I'm going to keep going. And what I'm going to do is I'm going to cancel out those two Q's, keep the 1 over here, and we can see that the change in average cost depends on marginal cost and average cost. clear, C prime Q. So if the marginal cost is greater than average cost is increasing. If the marginal cost is below average cost is decreasing. Now, what does this look like on a diagram that you might have seen in Econ 1000? Well, if I draw something like that, I've got my average cost curve, and it looks like that. And if I draw a marginal cost curve, and I draw some marginal cost curve, you know from microeconomics, and let me make sure we've got Q over here, and then we've got some sort of dollar price or the cost per unit, and you know from Econ 1000 average cost is minimized where MC is equal to AC. And that point is right here. And so that's what the mathematical expression we had previously is telling us. If I go back and show it to you, we've got marginal cost here, and this is average cost over here. If marginal cost is less than average cost, then we're going to be over on this side, because we've got AC, MC over there, and average cost is decreasing as Q is increasing. If marginal cost is above average cost, then we're going to be over on this side of the diagram. The last thing I'll say about this example is notice that we don't really care too much about the Q. So Q tells us something about quantities, and that might be important, but MC and AC are not just telling us about quantities, they tell us about the sign. I guess it should be, well, I guess it should have been F. It should be F of Q here. This should be a Q. So I'll have to fix that on your slides. Here's a question for you. Try and use the quotient rule on this, this function. Okay, go ahead and press pause if you want to keep working on it, and I'll give you the solution. We want to take the derivative of the numerator, and that's going to be 4x cubed according to the power rule, and we want to multiply that by x squared plus 1, and then we want to multiply this whole thing by the derivative of the denominator, so we get 2x multiplied by x to the power of 4, and the whole thing divided by x squared plus 1 squared. Now, again, sometimes I'll ask you to simplify if it's a really simple operation. If it's more complicated on a test, I might not ask you to simplify it, so you want to be aware of that. Think of that. Read the question. Make sure you're answering what the question is asking you to do. Here, let's try some simplification, see if it gets any less ugly to look at. So we've got f prime of x is equal to 4x to the power of 5 plus 4x to the power of 3. So I'm just opening up that bracket there. And then I've got negative 2x to the power of 5. And I don't think squaring the denominator is going to get us anywhere. So I'll just leave it. Now looking at the numerator, I have some like terms. So I've got 2x to the power of 5 terms, and there's a negative sign. So we're going to get 2x to the 5 plus 4x3 divided by x plus 1 squared. And I could factor out a 2x cubed, and that would leave an x squared plus 2. And we're stuck. And so that's as much simplifying as we can do with this expression. Now, before we end the video, sneak peek, the quotient rule can become the product rule. So I'll look at this in detail in a later section, a later video, but I just want to show you very quickly that I could rewrite this expression to get rid of the quotient, or to avoid the quotient rule. And now we've got f of x times g of x, and where g of x in this case is going to be equal to x squared plus 1 to the negative 1. But we have a problem, which is we don't yet know how to take the derivative of this thing. And that is the subject of our next video.